stream here. Okay, so let's continue with the streams. Fine, the streams we had seen yesterday were 4 plus 2, 5, 6 of them. Okay, now let's begin with the file-based IO, file IO. Okay, so for file IO, yes, which are the stream classes which we may be using? So we have, okay, so considering them as byte streams, we will have a class called FileOutputStream for the purpose of writing. Okay, fine. This is for output, and we have the file input stream for reading. Fine, for writing and for reading from a file. So these are the base classes. Okay, one is for writing, other is for reading. Okay, fine. And what we have here is we have the subclasses. Okay, so for example, yes, like a file output stream, we even have a FileWriter. I can put it there itself. Okay. These two classes, FileWriter is extending from output stream writer. Okay, and this is a subclass of input stream reader. Okay, fine. So clear? Fine. The idea here is okay. So these are nothing but you want to read as text from a file. So this is normal reading from a file as a bytes, and when you want to read as a string and char type, you can use a file write. Oh, you want to write basically. It's a file writer, and so here it's nothing but a special case of a output stream writer, wherever output stream is the file output stream, and char set is the default character set. You can't specify. Okay, so constructors for these two will be same. Okay, these two things. Okay, that constructors are the same set of constructors, because when I create a file writer, it has to just create a file output stream. Okay, and when I create a file reader, it internally has to create a file input stream, because that's my source now. Okay, fine. So now let's look at, maybe let's start with the file output stream. Okay, so file output stream, if you look at it, the constructors here. Okay, so what are the constructors for the file output stream? So if you want to create a file output stream, you'll have, it's a file which you would like to put into, right? So yeah, the constructor for file output stream will need as a string a file name. That's the most simplest way of doing it. Okay, and another constructor is where instead of a string as a file name, you might be using a object of the file. Okay, we understand. So okay, where I've said file name, it basically is, you may use a full path, and just like in the file class what we were doing, and so it's representing some path, right? Okay, fine. Now one more thing what we can do here is that it's been overloaded. Okay, okay, before I put that, yeah, so when I create when I call the constructor of file output stream, what would be happening? What would happen? Just calling the constructor. For example, if I say I just say new file output stream and give some file name abc.txt, maybe something like this, what would happen in this case? Just this statement, execution of this statement. Okay,
it will try to locate the file.
it has to create a new file. There's nothing like locate. Why should it locate?
Let's say if the existing file I want to append to.
This will not do that. Okay, so yes, you raised a question about appending. That's where the overloading is done. So you have to pass a parameter as true. Only then it thinks about appending. So if you want, you can have a append mode. So these are overloaded. Okay. So there are four files. So we can understand these are the four constructors we'll have, right? So if you don't specify the append part, that would be false, right? Okay, but we still have one more constructor. You can create a file output stream by using a file descriptor. And we can always use a file descriptor to create a file output stream. Oh, what is this file descriptor? Okay, let's try to understand what is a file descriptor. Fine, so 5 constructors for the file output stream. That's one thing. Okay, let me put some methods here, and then we'll come back to what the file descriptor is. Right? Whenever any file is opened for reading or writing, fine, for any purpose, fine, a file descriptor has to be created. There is a file descriptor allocated. It's like a handle, fine, through which the I/O will take place with the operating system. Fine, on the file system, any I/O, if it has to be done, there has to be some kind of a handle available to that process. Okay, so it's like a handle to the file for a purpose of I/O to the fine. So okay, I'll remove this. Okay, now if I look at the methods, yes, we have methods, all methods from superclass. This is output stream, yes, so we'll have all methods of the output stream. Additional methods, okay, so there's one method to return a file descriptor. Since you have opened a file for output, it has a file descriptor, so we have a method called getFD to return that file descriptor. Okay, and we even have a method to return a get channel. Okay, now that file channel we are not currently dealing with. This is nothing but part of the java.nio.channels package. Okay, it's part of the java.nio.channels. Like Java 1.4, when it introduced the java.nio, fine, the idea is that yes, we have the, instead of using an input stream or an output stream, we would be using channels. So there is a byte channel, okay, readable byte channel, writable byte channel. Okay, so we have something like readable byte channel and a writable byte channel. File channel is both a readable byte channel and a writable byte channel. Those were interfaces, basically channel and interfaces. But file channel is a class which is implementing readable byte channel as well as writable byte channel. Okay, there the method which is used for reading or for writing, the method name is read, but the parameter would be the buffer, a byte buffer. So it always has to read. You can't get one, I want to get 1 byte from the file or something. No, you can't get it when you use channel. You must create a buffer first, use it as a parameter to a read method. So it will always read into a buffer. Or you have a buffer with some data already, populated with some data. You use a channel, give that buffer to the channel, then it will go to the destination. So we have use of channels basically. That is what Java NIO has done. Okay, so Java NIO has the channels. So this is just nothing but a link between your byte stream and the IO and the NIO. Okay, NIO was using channels. So if you want for a file output stream, you can get a corresponding, create a channel out of it also. Okay, so that's the only purpose here. Fine. So additional methods are only these two. Okay, so whenever a file is opened for output, okay, a file descriptor is created. Any file is opened for any purpose, yes, a file descriptor would be created, and that's what is available with the method called getFD. Okay, now one more thing about the file descriptor. We have this class called file descriptor that's in the java.io package. So in the file descriptor also we have the classes. This has a few public, static, final, variable of the type file descriptor, okay, in, variable name is in, equal to, and yes, it has some way, it has a mechanism by which it has been able to create an object which corresponds to the standard input. Okay, so a file descriptor for the standard input file, which normally will be our keyboard to read from the keyboard. Yes, so we have a file descriptor called FileDescriptor.in, static variable. Okay, same way, what are the others? Okay, standard input. Okay, fine, same way, yes, we have the out and okay, we have the standard input, standard output, standard error, file descriptors corresponding to them. Okay, so anytime a file, these are always open for any process. As soon as the JVM would start, it would have a standard input, output, and error. If someone has done a redirection, yes, it would correspond to that. Okay. Now, what happens when someone uses that constructor here for file output stream, which uses a file descriptor? What do you think? What is that? What happens here? What it really implies is you may have a single physical file, but you might still be having multiple file output stream which would write to that same file. You have opened one file, okay, fine. So you might have created one file output stream. I'll give an example like this. I have created a file output stream. Okay, and some file name is given. Okay, fine. And then someone gets, okay, let me, so at some other part of the code, it says, okay, let me have a file output stream. You might create a file output stream like this. Now, whether you write FOS.write and whatever the parameters you may have used, or FOS2.write, it goes in the same file. Okay, fine.
Different file outputs.
Yeah, so there can be multiple file outputs even they still correspond to, or you want to write to the system.out, same thing, that standard output. I could create a file output stream, okay, std out equals new file output stream, and I will use the file descriptor dot out. Yeah, okay, and you write here, where is it going to go? The same place as system out. Fine, clear about that file descriptor. Fine, it's just a handler, fine, which is available to a process whenever any file is opened. Okay, fine. So we find this method called getFD and even the getChannel method. Okay, they would be available also in the FileInputStream. Okay, fine. I'll just show you some the classes with these two methods. Okay, which are the classes which have these two methods. Okay, so we have methods common to, one is the FileOutputStream, and there's another class called random access. And so these three, all of them have these methods. Okay, and that's a pair of method. Oops. So the idea is, yes, to be able to use the channel, if you want to use the NIO based input output, once you have created a file input stream, output stream, or a random access file, you have opened the file. Okay, we have this file reader and the file writer classes. They don't have these methods. They are just internally using the corresponding file byte stream. Okay.
This getFD and getChannel is only exclusively available
In these three classes. Yeah, because that's where the file is open. Fine. Okay. The other, the file reader, file writer, they work with the file.
So this there can be multiple file descriptors for a single file.
Physical file.
For a single physical file.
One file which I have opened, I have one file descriptor.
One process has opened that.
And that file descriptor can be used. So even in, okay, so this is what we saw with the file output stream class. That we have a constructor where a file descriptor can be used. Same thing for the file input stream also.
So input case, it's
Same.
understandable, but for writing there can be contention.
Yeah.
Writing.
Where is the contention? It's only one after the other, no? You have used this one, so okay.
Simultaneously, two processes tries to write to the file.
Okay, that simultaneously two processes may write on the same file output stream. Then also that same question arises, right? If you're talking about simultaneous, there is a concurrency. You're talking about threading. If it's a multiple thread, concurrency is occurring. It can occur even with one. Where's the question of file descriptor? Two file output stream objects. Even with one file output stream object, that can happen. The contention which you are talking about, that has to be taken care differently.
Yes, some other processes, yeah.
Yeah. Okay.
The concept of multi-threading would be used here.
That anyway is there for so many places. It's not just here. So, fine. Our whatever we have looked at is okay. One thread working on it, right?
No, so actually, I'm trying to understand the use case for this file.
Okay. So in some testing purpose, fine. Sometimes let me put it in that same place. Okay. Sometimes you may write to put it into some other place. Okay. Okay. See, it's like this. You create an object of a, let's say, for the purpose of output, if you are looking at. So this is for some file output stream, FOS, let me say, right? Okay. When you created it, fine. This has an object of a file descriptor. This is your file descriptor. which it has got. Okay, this file descriptor corresponds to a physical file on the file system. Right? You can use this file descriptor to create another file output stream. Right? If you write from here, you write some data here, that goes here. If you write data here, it's still going through the same file descriptor. So it's just like, okay, it will be just appending each time. When you are writing, it's always append. Okay. Only in the constructor, we are saying if existing, retain, append at the end. Start appending, don't destroy it. I want the earlier data to be available, right? In that case, you'll just say append mode. Okay. If there are logs being written out, you are writing some kind of a log, a file opened for writing a log. Okay, it would be append mode. When clear this file descriptor thing. Okay. And file descriptor is not only for file, because even the file descriptor would be available. It's not here shown here, but yes, at the OS level, right? If you look at the C language calls, even a network connection, a TCP/IP based network connection, fine, that's a socket, and that also has a file descriptor.
Socket is also
Yes,
a file descriptor.
it's like a file only.
It's an abstraction. So
Yeah.
basically, we write to the file descriptor.
Yeah.
Will send it to the socket.
Yeah. And in C language, yes, there is a file descriptor when we have a TCP/IP connection. Okay, and then you use that file descriptor always to write. Reading or writing is from that file descriptor. Okay.
It can be basically, I think, software. It can be some device also. Device?
Yes. See, on Linux, everything is a file. All devices are available as file. Okay. Fine. Fine. So clear with this file descriptor concept? Okay. Fine. Yeah, one thing, any process, if it is started, it's not only the JVM which is started. Any process, if it is started, right, it gets 3 file descriptors. There is a process, right? Okay. It opens up 3 files. Okay. So there is a file descriptor for each of the files which is opened. There are those file descriptors. One is in, out, and ERR. The standard input, standard output, standard error. As you create a new file output stream or a new file input stream, then that one more file descriptor will be allocated for it. These actually get a numbering starting with in is 0, out is 1, and error is 2. Okay, and this number is useful when you try to redirect. Okay, fine. Commands, output of a command is going to be redirected. You redirect the standard input output error into a file or from a file. Anyway, standard output, standard error have to be going to a file. Standard input comes from a file. And you use the lesson for redirecting standard input. Okay, fine. If you just say greater than, you are redirecting the standard output. How will I redirect the standard error? To redirect the standard error, what do we need? No. Standard error, what's the number?
Actually, 2 greater.
2 greater than. 2 greater than. That's for the standard error. So redirect standard error using this. Okay. Fine. So it's like some command here, okay, and that's your file name. You can do one more thing. You can say, okay, I have some command, okay, redirect this into a file, and you can say 2 greater than, and then another file. Okay, fine. When you write a command, yes, you can redirect both the things or all the 3 things, less than, and give one more thing, one file name. So input comes from this file. So any scanf, fine, for C language it's a scanf, but that's going to read from that file, not from the keyboard. Fine. Any printf, that's going to go into the other file. Any eprintf, that's going to go into the other file. So redirect these things. Okay. Fine, clear on that aspect now. Okay. Fine. So yeah, so for the purpose of file IO, yes, we have these. Fine. File descriptor is what is useful, and we have these classes. Okay. So file output stream, yes, we have seen the constructors, we have seen the additional methods. Same way, if we look at a file input stream, okay, and the constructors, fine. What are the constructors? A file input stream can be created from a string by giving a file name, or yeah, what's the other thing? There are 3 constructors. You can be using a file object, or you may be using a file descriptor. Right? Okay, additional methods, we know those 2. Otherwise, methods are from the superclass. Whatever methods for input stream, that's a method. Additional method are only those 2. Okay, fine. If you look at a file writer now, okay, file writer, okay. So we have those 5 constructors in the file output stream. Fine, same thing for the file writer. Fine, append mode can be specified. We can't specify the char set. So if you would like to use a specific char set while writing to a file, what you should be doing? Output stream writer. Clear? With output stream writer, you have more control. Remember that. This is a special case. That's it. Specific case where only default character set will be used. You don't have control on the char set to be used. Okay. Methods from which is the what's the superclass for file writer? It's output stream writer. And if you had seen that output stream, the bridge class, right? Because destination is a byte based. Okay. Fine. Similarly, if I look at a file reader, fine. So here you don't have method like getFD or getChannel. Okay.
This file writer will basically get all the methods from output stream writer, but it will always work with the default character.
Yes. You can use the get encoding method, which is available in the output stream writer to know what encoding it is. Fine. Constructors same as, so this is fine. So file input stream. Okay, and all methods from fine. Clear?